Welcome to PV Online. We're going to take a look at a problem dealing with constant velocity and constant average speed. All right, so we have this example where Amy's running along a straight road, 4,300 meters directly south. Since physics is such a visual science, I'm going to draw a little arrow representing her going south, and that's the 4,300 meters. Let me see if I can move the pen around. I'm having a heck of a time with this. All right, and then she stops and realizes she wanted something at the store, so she backtracks and goes up 7,200 meters north. Now, the reason I made that arrow longer is because I know that 7,200 obviously is larger than 4,300, so that tells me that she's going to end up north of where she started. So for part A, you're asked to find her displacement. Now, remember, in displacement, it doesn't matter how far you've gone, just how far are you from where you started. So in reality, what I'm looking for is I'm looking for this distance right here. This is going to represent her displacement. She started there and she ended up a little bit due north. So for the displacement, which we're going to use the symbols delta x to represent that, I'm going to make this negative 4,300 because I'm going to make anything pointing down negative, which means that the 7,200, since it's up, is going to be positive. And that means she ends up 2,900 meters north. All right, so we've got everything. That's delta x. Okay, now for part B, we want to find the distance that she traveled. Now I just want to know how far did she go. So the distance then is simply going to be, there's not going to be any signs because direction doesn't matter. So I'm simply going to add up the 4,300 with the 7,200. And that's going to give me, how about 11,500? Meters. All right, now for part C, it says, if the trip took 3,000 seconds, find her average velocity. By definition, we said that average velocity equals the displacement divided by time. That means her average velocity is going to equal the 2,900. Is that right? 29? Yep, 2,900 meters divided by our 3,000 seconds, and that's going to give us an average velocity of 0.967, and we can't forget units, so that's going to be meters over seconds. Now let's compare that with her average speed. By definition, average speed is going to be the distance that you go divided by the time. And the average speed then is going to equal the distance, which was 11,500 meters, divided by the 3,000 seconds. And that's going to give us an average speed of 3.83 meters per second. Now, the reason that they're different is because she changed directions. If she had just been going south the whole time, then the average speed and average velocity would have been the same. Now, in reality, what I should do is up here where it says average velocity, in addition to giving you the magnitude, which is the amount, the 0.967 meters per second, I also should say here that she ended up due north to give the direction. All right, you should be ready to start the problems. Good luck.